Welcome to this class, and in this class I want to teach you about function modifiers in Solidity. What are function modifiers? They are piece of codes or a block of code, a specialized function that is responsible for changing the behavior of another function. So I write a certain behavior that a function should incorporate, and when I attach this behavior to another function, that function starts behaving according to that design that I've made. I don't know if that makes sense, but I want to show you for an example right here. So for example, we have a function called, let's say we have a variable called owner, which is an address type, and let's call it, this is public, of course, and let's make it private. Okay, private for the sake of this tutorial, let's make it public. So it's public and it's called owner, and once it is deployed on the network, I want the owner to become the sender or the deployer of the smart contract. So now this is a function, a function called withdraw. Okay, and let's say it is external, doesn't really make any difference, returns true, returns boolean, of course. Okay, and what it does is, let's say it returns the address, address type, and it just returns this particular address called owner, returns owner, and let's make this owner to be private by default. So you see, anybody can call this function right here. For example, let me clean up this and deploy it to the network. By deploying, you have to compile Ctrl S to save. There's a warning here saying be restricted to view. Okay, so save view here, compile, and it's all good. So when you deploy this smart contract, you check it out here, you see that I could call this right now. I come here, change my account. Imagine that this is a function that is withdrawing money, and as you click on this again, it still called that and it's returning the result. Imagine that anybody can just withdraw money from you. You don't want that kind of behavior. In the recent tutorials, I taught you how to use the require function, by you just attaching it like this. Require that when you do something like it, requires that the sender or the caller of the smart contract is equal to the owner. Okay, say as an unauthorized entity. Okay, this particular line of code resolves that thing here. So for example, I deploy and I call this function right here, and it's returning. So now I change my account and call it with this other function. It returns an unauthorized entity, as can be seen here. So it works, it serves the purpose. But what if I'm creating a very large scale smart contract, that has bulk of code and bulk of usage where this particular thing obstruct or constraint should be put in place? I don't want to be writing this line of code every single place. It just make it repetitive and redundant. You want to make your code clean, so you want to refactor it into one piece of function, and that is where function modifiers come into play. So for example, I'm going to come here and create a function modifier called owner only. How you create a modifier is by using the keyword modifier, and then the name of the modifier, let's say owner only. So, and if a modifier of, we have a parameter, and you can pass arguments inside of it, but I'm going to show you how to do show you that. For example, so I could come and say what does it do? it's basically just let it implement this line. Okay, implement this line, and you will have to end the function modifier with this line of code here, like that, like this. This is how you end the function modifier. So with that done, all you just need now to do is to attach this function modifier here, say owner only. Okay, so now when you compile, see that it compiles good, and I deploy. It's on the network. Okay, I call this, you see that it's working, returning information to me. Now let me change my account to something different like this one, and then I call it. You see, it tells me that what unauthorized entity. You see how clean this is? Now you can use it in all the functions that you can create, and you can just attach that keyword owner only, and it will just serve the purpose that we're trying to include all this in every line of code. See how simple and clean it is. One thing you can even make it a lot more cleaner and a lot more dynamic is to actually include a message here, and let that message now be passed like this, message. Okay, this will be the message that will be passed inside of here, and you can now call this function this way and pass in the message that you want to do. Compile. Of course, Solidity is a statically typed programming language, so you have to include the data type, and when you click on that, it's going to say you need to specify the location where this particular thing is going to be put into. It's going to be stored. Let's use call data, since we are not doing any kind of computation. Save, and it's not agreeing, so let's before we do that, says that invalid type of argument, so let's do, it's not called data, so because it's not coming from the outside, so now let's change it to memory. Okay, and compile, and you see that it works. So call data, one thing you must know is that call data is a parameter that is passed down into a functions a param that is passed down into a functions parameter that is coming from the caller and outside, but this isn't really coming from the outside, it's coming from inside this smart contract, so it's rejecting it for that reason. So let's call this memory. Of course, save it, it's compiled now. So now I could make this message dynamic, and say unauthorized personnel. Spell that correctly. Compile and publish or deploy, and at that, click on withdraw. It works. Now let's use a different account like this, and click on this withdraw. It fails. Unauthorized personnel. Do you see that? So this is how function modifiers work in Solidity, and they are very useful, very instrumental, to make life easier for you as you use Solidity. Hope you got some awesome information from this video. I am gonna see you in the next one. Bye.